All right, this is going to be our first of maybe 2 or 3 videos about polar equations. Today we're going to spend some time talking about mostly Rose graphs, and then some other introductory things with polar equations. Um, what I'd like you to do is, uh, at some point, probably just right now, open up a Chrome browser tab and get yourself to Desmos. All you have to do is just type in desmos.com. Uh, just click Start Graphing and plug in into the um, empty box here with the cursor blinking in it. Just type in uh, R equals, which means that we're going to be doing a polar graph. Um, let's start with, I don't know, how about 5 cosine of 3 theta. And then to do theta, you can click this little keyboard thing down here and then look for it there. But you could also just type the word theta. It'll change it right to theta. Okay, and then what you're also going to do is you come over here to your settings and change this to right here. We're going to click the polar uh, grid so that now this is our polar background. Um, I'm going to zoom in here so we can take a look at what we have here. Pretty cool shape. This is called a rose graph. Um, what I'd like you to notice here is the connection between this rose graph that we have here and then the numbers we put into this function. We have 5 cosine of 3 theta, and if you can tell here, 5 is the length of each of these petals. It's the R value at the tip of each of these petals. Remember, in the polar graph, R is the distance from the pole right here to any point. So this point right here, this petal tip, by the way, these things are called petals here. This petal tip is 5 units away. The other thing I'd like you to notice is there are 3 of these petal tips on this graph. So the 5 is related to the length of that petal tip, and the 3 is how many petals that we have right there. Um, so I'm actually going to do this. R equals, I'm just going to say A cosine of B theta. And we're going to add sliders for both A and B here. I'm going to turn this guy off. All right, so if we made A, we could have the same exact graph that we just had. So we have A being 5 again, and B being, what do we have B as before? 3, right? So this is the same graph that we had before. Okay, so what I'd like you to notice is if I change that A value, all it's going to do is change the length of those petals. And if I change the B value, remember we said there's 3 petals because it's a 3. So if I change the B value to 4, what I'd like you to notice right away is that all of a sudden there's 8 petals. Okay, if we go up to 5, there's 5 petals. 6, now there's 12 petals. So anytime we hit an even number here for this value, or I should say this value for B, anytime we hit an even number, we have twice that number of petals, but every time we hit an odd number, we have that number of petals. I have 7 petals here now. Okay, so I'm going to go back to that value of 3. So we have 3 petals here now. In this cosine graph, what I'd like you to notice is we are symmetric over this x-axis. Okay, we could flip that thing over the x-axis onto itself. If we had a sine graph, so I'm going to do the same exact graph, r equals, but this I'm going to make it sine b theta. So now that black graph, there's a sine graph. Notice now this one is symmetric in the y-axis. So cosine, if you have an odd number of petals, is symmetric in the x-axis. Sine is symmetric in the y-axis if there's an odd number of petals. And I say odd number of petals because if I switch this now to, let's go up to 4. Now I have 8 petals. Notice the sine graph here, we are symmetric in both axes. In the cosine graph, we will also be symmetric in both axes, both x and y. So if you have an even number of petals, it's symmetric in both axes. So let's talk about that rose graph now a little bit more on our actual notes. All right, so let's take a look at our notes here. Let's talk a little bit more in detail about what's happening. So let's talk about cosine here first. So our cosine graph has its first pedal tip will always be the tip of the pedal point will be at this coordinate r comma theta. So polar graphing, remember r comma theta. We're going to be a units for r, and our theta value will be 0 to start with. So we're going to open up 0 radians and be at a value of a, or at the maximum value for the cosine graph. Uh, the cosine, excuse me, the sine graph, on the other hand, the first pedal tip will actually be about, not about, at exactly 1/4 of the period, and we'll talk about what the period is in a second, of the graph. 1/4 of the period is what that first pedal tip will have its angle be at. Uh, the A value will still tell you how far it is away from the pole. So this is, remember, r comma theta. R is how far it is from the pole. Theta is the angle that of the terminal side that it's on. So 1/4 the period. I'm going to come down here right away and actually just tell you what the period is. The period is 2 pi over n. Okay, so look at where n is. Well, this is the same thing that we used for our period of sine and cosine back when we were graphing these in the xy coordinate plane. So 2 pi over b, 2 pi over n, same idea here. So 1/4 of that would be pi over 2n. So you can take your period and multiply it by 1/4, or you could just do pi over 2n. That's the angle that the first pedal tip will be at for sine. So the stuff in this box here is for both sine and cosine. The pedal length is A. It's actually the absolute value of A, although we won't be dealing with any negative A values, but it's the absolute value of A is the pedal length. And then N is used to determine the number of pedals, as we'll describe down here. If N is even, then you're going to have 2N pedals, so double the number of pedals. And to get from one pedal to the next, we're going to add half the period to each pedal tip, and it'll be symmetric in both axes. Okay, this will make a little bit more sense when we start referencing how this connects to graphs that we've done in the past. But just know for right now that for even, you got to go all the way from 0 to 2 pi in order to get the whole graph. For odd functions, you actually would only need to graph values of theta from 0 to pi, because once you hit pi, all those points start to trace over the graph that you already have, which is why we have half the number of pedals. There's only n pedals with an odd n value. To get from one pedal tip to the next, we have to add a whole period, one whole period, unlike this one where we said we had a half period. Well, that's because we had more pedals if it was even, so we added less to get from one pedal to the next. For the odd, we had a full period. And then the odd functions are symmetric in the x-axis for cosine, and then the y-axis for sine. All right, so what we're going to do first is we're going to do some of the symmetry stuff in the next video. Right now, I just want to graph some of these polar graphs. So the first thing you should notice here, when you look at a polar graph of this form, so notice this is the form that we were just talking about. You have n sine of, n, r equals a sine of n theta. So n here is 3. So that means since it's odd, we have 3 pedals, that same number of pedals. Okay, and since it's sine, we know a couple things. We know it's symmetric in the y-axis. And this is not stuff that you would normally write down for every problem. I'm trying to set this example up here. It's symmetric in the y-axis, but the most important thing is that the first pedal tip, because it's sine, first pedal tip is going to be at 1/4 of the period, or pi over 2n. Okay, so actually, let's come down here and talk about what the period is first. I'm just going to put that in a spot. Maybe I'll do it up here, like it's like the first thing we did. The period is going to be 2 pi over n, or 2 pi over 3. So 1/4 of that would be pi over 6. So the first pedal tip is going to be at, let's just remind us where we're getting this from, is going to be a comma pi over 2n, which means it's going to be at 4, that's our a value, comma pi over 6. And you could also say that that's 1/4 of the period. Little notes to ourselves here. Okay, so let's graph that polar point right there. First, I'm going to scale my graph out here. I'm just going to say each of these red lines is 1 unit. So we've got 1, 2, 3, 4 here. Go to 6. Okay. But our maximum R value is just the 4. That's our pedal tip. That's as big as this thing's going to get. So I only always just scale up that one axis right there because those values go all the way around. It's positive all the way around. It's the distance away from the pole. So at pi over 6, which is right here, we're going to have our first pedal tip 4 units away from the pole. There's our first pedal tip right there. Okay. In a future video, we're going to talk about the connection between what we're about to graph right now and the graph of y equals 4 sine of 3x like we've done in the past, where this thing would look like this, right? That's what a sine graph looks like if we graph it in the rectangular coordinate plane. It would have an amplitude of 4, so we go up to 4, down to negative 4. We already said the period is 2 pi over 3, but what we'll do is talk about how this translates to that in a future video. For right now, all we're going to do is draw our pedals, and the width of it, you get kind of used to how wide to make these things. We're not going to go into the detail of, how you figure out how wide this is from there to there. We don't even cover that in this course, so don't worry about it. We just want these pedals to look nice when we're done. They don't overlap each other, so you can't make them too wide. You get kind of used to it. All right, so that's our first pedal tip right there. Now, because there's an odd number of pedals, and you can get all this information from up above, we will add the period. We'll add that amount, add that to get between pedals. Okay, so from that pi over 6, I want to add the period, pi over 6. To that pi over 6, I want to add the period 2 pi over 3 in order to get to the next pedal tip. So if I added 2 pi over 3 to that, I'm going to get a common denominator right there. There's 2 pi over 3 with a denominator of 6. That would give me my new pedal tip, which is at 5 pi over 6. So 5 pi over 6 is right here. So I know that 4 units away, I'll have my next pedal tip. So here's my next pedal. And I'm just going to make it this other color so that we can kind of see which work went into getting which pedal. And then to that 5 pi over 6, I'm going to add another 2 pi over 3. Okay, oops, let's keep our common denominator here, 4 pi over 6. All right, and that's going to give me 9 pi over 6. And 9 pi over 6 simplifies to 3 pi over 2. But that should make sense to us, because remember, this is sine and it's symmetric in the y-axis. So there's no way I could put anything over here, because if I reflected over the y-axis, I'd have another thing over here, and that would have 4 pedals on. We know this is supposed to have 3 pedals. So it should make sense that my third and final pedal is going to be on the y-axis and look like that. Right? And when I get done, I usually will just kind of like fill these things in just so I can see it a little bit better. These graphs that I gave you guys are kind of dark. It's kind of hard to see the lines on there, so that makes it kind of easy to see. So that's our first rows graph right there. Going to the next side here, we again have 3 pedals because our n value is 3. This time it's cosine though, so we're going to be starting a little bit different spot. And the maximum value, the maximum R value is 3. So we know our pedal tips are going to be 3 units long. In fact, I'm going to put that over here. There's 3 pedals and their length of 3. All right, so I'm going to come over here and scale this out again. I'm going to go a little bit bigger this time and call this 1, 2. So every 2 red lines, I'm making 1 unit, just so I can see this a little bit easier. All right, so I have 3 pedals. Now the cosine graph. Cosine has its first pedal tip. It's going to be symmetric in the x-axis. The first pedal tip is going to be at always, I'll just start with the r comma theta here again, always at whatever your a value is, comma, actually, how did we write that in the last problem? we wrote that it would be at A comma 0, so it's going to be at 3 comma 0 there. Try to do this problem the same way we did the last one. So at 3 comma 0, now that 0 means open up 0 radians and then go 3 units away from the pole. So 0 radians, 3 units away from the pole would be right there. So my first pedal tip is going to look a little something like this. Okay, which makes sense. Cosine is symmetric in the x-axis. Looks good so far. And now our period for this graph is 2 pi over 3 again. Okay, now here's, same as the last one. That's the amount that we're going to add to get to the next pedal. So my first pedal tip is at 0, and then I need to add 2 pi over 3 to that to get to the next pedal tip. Well, obviously that gives me 2 pi over 3. So that's going to put me right here. Here's 2 pi over 3, so it's going to put me right here. Here's my next pedal tip. And then I'm going to add 2 pi over 3 to that and get 4 pi over 3. That's my third and final pedal. Because remember, we only are going to have 3 pedals here. So that's going to put me right here at 4 pi over 3. And there's our graph. Symmetric in the x-axis because it's cosine. So it started on the polar axis right there, 3 units away because A was 3. There's our polar graph there. All right. Now we have one that has an even number of petals. Since n equals 2, we have 4 petals. And they're all going to be a length of 5 because of the A value there. So scale this out here. 1, 2, 3, 4, 5. And you can scale it out however you want as long as it's to scale. Okay, because it's cosine, we're going to be starting in the same spot that we did last time. So I'm just going to put that the first tip is going to be at A comma 0, which is 5 comma 0, which is right here. And the period here is 2 pi over 2, or just pi. Okay, but here's where things get a little bit different from before. Since it's even, that means that we need to add half the period, which is pi over 2. I'll just write that that's half the period, to get from one pedal to the next. I'll just put between pedals. So if I add pi over 2 to that, that's going to put me up, well, at pi over 2, comma, or I should say at 5, comma, pi over 2. And if I add pi over 2 to that, I'm going to be at pi. If I add 5 over 2 to that, I'm going to be at 3 pi over 2. And those would be my 4 pedals. So I've got that first pedal right there, second pedal, third pedal. What we're going to find out in the either the next video, probably a third video, kind of a supplementary video, is that's really not the order that this is graphed. It really is graphed in a little bit different fashion. This is the fastest way for us to get a good sketch of what these look like. The way that it's actually graphed, actually I'm going to take a second to show you that in this one. The way that that's actually graphed, I hope I don't screw this up. It would start at that green point that we put first, and it would come back through, go back down. So this is the actual way that that graph would be graphed. Probably should finish it there. So it actually started, okay, where we had our first point. It came back through to the pole, then down, then back up, then here. I'm just going to put these arrows in the direction that this thing opened up in, and then finally it ended up there. So it started there and it ended there as well. And that'll be in another video where we talk about, how that where that comes from, how that connects to the graphs that we've done in the past. So our last polar graph here, we're going to have 8 petals here because of the 4. Okay, each time I'm writing like a little bit less information. 8 petals here. It's a sine. It's going to be, well, but because there's an even number of petals, it's symmetric in both axes. I should probably point that out here. Symmetric in both axes. Doesn't matter sine, cosine if it's an even number of petals. So we're going to be symmetric in both here as well. The A value is 3, so they can have a length of 3. I'm going to come over here and just scale this here real quick. We'll go 1, 2, 3. This is going to be a pretty crazy looking graph. I'm going to go all the way out and have 8 petals. So let's talk about where it starts. The first petal tip. First petal tip for sine is always at a comma and then 1/4 the period, or pi over 2n. Well, that's going to be 3 comma. All right, I always forget to do that period first. Period here is 2 pi over 4, which is just pi over 2. So that means that the period, or 1/4 of the period, is going to be pi over 8. So our first petal tip is going to be at pi over 8 as a terminal angle, and then I'm going to go out 3 units. So we got to figure out where pi over 8 is in here. Well, this is pi over 4, right? Well, pi over 8 would be half of that, so it's like 1.5 of those units going up. That's pi over 8 right there. What I'm going to do now is just make sure I go around. I'm going to mark every pi over 8. So it's like every 1.5. I'm just going to put a little mark here because I know that that's going to be pretty useful in our graph. So this is every pi over 8. You can fast forward to this if you want. It's not too bad. All right, so first we're going to go to pi over 8 and go out 3 units, which would put us right there, actually. Okay. We have an even number of petals, so we have to add half the period to get to each petal. So just say add pi over 4 between petals. Have some little notes to ourselves here. So if I add pi over 4, that's going to put me at, every little notch that I just put in there is pi over 8. So every 2 notches was pi over 4. So my next petal is going to be there, and then there, and then there, and then there. And then when I'm done, it should be symmetric in both axes here. And I should have 8 of those dots, which I do. And so now we're just going to draw those petals in. That one got a little out of control. They really shouldn't be overlapping one another. Make a little bit, so I'm probably making these a little too wide. There's our last petal right there. 8 petals, symmetric in both axes. And we went half of the period in between each petal. The period is pi over 2, so we went pi over 4 in between each petal. And that's that's our last rose graph right there. So what we'll do in our next video is talk about what are called limestone curves. I hope I'm pronouncing that correctly. You can see those here. If you want to play around with them, you go to Desmos and plug that sort of thing in right there, just like we did before. Make 2 sliders for A and B, and then play around, and then find out how all this information comes about. But then we'll do the rest of this in our next video.